Hello everyone, my name is Gurpreet Kaur and my partner Anup Gonzalez. Today we're going to talk about discovering the hidden connection between individuals. So let's get started. Let's talk about introduction. So the issue of social connection is one that defines who we are as a people. And social networking has skyrocketed in popularity over the past 10 years. Here are some statistics we have. So the past 10 years, with 72% of Americans now they're using at least one social media platform compared to just 5% in 2005. So these statistics shows that how we are using so much social media and how we are connected with new people each and every day. Let's talk more about introduction. So in social network, individuals are mutually connected with each other. The connection is a rival of massive network graphs with hundreds of millions of nodes. We will talk about edges and nodes more in detail in the few next slides. In this slide, we're going to talk about link prediction and objectives. We're going to talk about how we are connected to each other with the DeepWalk. DeepWalk is a novel approach for learning latent representation of vertices in a network. In these days, there are several superficial nodes that are secured by links, where we consider the nodes are people and the connection are the connection between network, such as we are using LinkedIn, Facebook, Instagram, Twitter, or other social application that impacts a huge difference in our life. And these types of networking helped us expand business, jobs, communication, socializing, FaceTiming, chatting, and other dating, etc. Slide we are showing how literature reviews mention similar works made by other people. So there are some link prediction are based on Markov chain and machine learning, and we have some predictions here.
Problem definition. Now, given a graph in which C represents the people on Facebook and E is the actual connection between these individuals, a subset of connection is found between people. And finding out the interesting hidden connection is required. The graphical representation to the left denotes this problem. And we can think of it not only as people, but we can think of it as communities, schools, any system like companies, right? But in this case, if we take a look at the graph to the right, we can see that there is a connection between Sophia and Maria, which could be any company, could be schools. And it is represented by straight black line, which denotes that there is a clear connection between these two. But then we take a look at Adam and Sophia, and we see that there is a black dashed line, which tell us that the connection between these two is hidden, so they are not aware of it. And the way this can help us is by providing us with information about our communities or potential employers, potential partners, in the case of companies. Um, all of this information, these hidden connections, can be useful in those cases. Proposed solution using the DeepWalk algorithm. The DeepWalk algorithm introduced use distributed word representation methods into the study of social network for the first time to learn vertex representation according to network structure. Now, graph data structures are used to illustrate complex interactions, and the powerful analysis are used to find different functions within the figure. However, they lack the capability to encode aspects of the graph for input into machine learning algorithm. And this is where the deep work is proposed. So interactions within graphs between neural networks can be captured and encoded. And there are several networks that aid in the deep work implementation, such as word2vec and skipgram, including the deep work process. And now, deep work first generates short random walks, which have been used as a similarity measure. And we will see more on this later on the presentation. And you have heard us talk all through that presentation about the deep work algorithm, the deep work process, deep work. But what exactly is the deep work algorithm? Well, deep work is an algorithm that is used to create embeddings or social representations of the nodes in a graph. And again, the nodes can be anything from people to companies to communities, schools, and all of these can be represented as nodes. And the deep walk uses local information obtained from truncated random walks to learn latent representations by treating these walks as the equivalent of sentences. In some experiments, deep walks representation are able to even outperform all baseline methods while using 60% less training data. And this is huge, especially when we are dealing with huge amounts of data to put into our graphs. DeepWalk uses something called skipogram. And what a skipogram is an algorithm that is used to create embeddings, or again, social representations of high dimensional vector representation of words. And these embeddings are meant to encode the semantic meaning of words such that words that are semantically similar will lie close to each other in that vector space. And here's a bit more of information in the deep work algorithm process. For each node, perform n random steps starting from that node. And then we treat each walk as a sequence of node ID strings. And given a list of these sequences, we train a word-to-vec model using the skipgram algorithm on these string sequences. For the experiment and result, if you take a look to the right, you can see the dataset used in this research from a statistical information presented here. And here you can take a look at the amount of nodes that we have had or the edges, which again, nodes represent the entity and the edges would represent each connection. So we can determine by this, we can see that there were about 17.2 thousand connections. More on the experimental result, here we can see that the word2vec, the vocabulary that was included in it was about 3,894 with a size of 100 and alpha of 0.03. And if you take a look at the graph to the left, you can see how each red node is an entity and all the lines connecting all of them are the connections between each entity. As a conclusion, we have seen that the DeepWalk algorithm and link prediction give us a better view of connections between individuals in our community, and it can be implemented to create new connections. But this doesn't only apply to people. As we have mentioned throughout this presentation, the DeepWalk algorithm serves as a way to represent also things like companies or corporations, schools, or any part of the community. And this is very helpful in cases in which, for example, someone is looking to hire some new employees, or someone is looking, a corporation is looking to form a partnership with another corporation. These hidden connections give us the key to approach these issues. For our future work, we are trying to dig deeper into the phenomenon of the hidden connections. But this time, we're trying to see and analyze how individuals from different backgrounds or different ages are connected to each other based on the music that they listen to nowadays. This is the end of our presentation. I want to thank everyone for listening to it and making it through the end. Thank you.